In the grand ballet of the universe, every celestial body has its role. Some stars flicker dimly and endure for eternity. Others shine with the power of 1,000 suns but live brief, violent lives. This is the story of one such titan, a supermassive star at the edge of existence, teetering on the precipice of destruction. A star like this was born in chaos. Millions of years ago, it emerged from the collapse of a vast molecular cloud, igniting in nuclear fire. Now it stands at the threshold of its ultimate fate. This is not just death, it is transformation. A supermassive star is born from the ruins of the past, clouds of hydrogen and helium collapsing under their own gravity. As the pressure mounts, atoms collide, and the first flickers of fusion ignite. A star is born, a monster has awakened. At its heart, a supermassive star is a furnace, a reactor where matter is torn apart and reborn. Hydrogen fuses into helium, helium into carbon, carbon into oxygen, neon, magnesium, silicon, and at last the element that spells its doom, iron. For millions of years the battle has raged, fusion against gravity. But iron is the final adversary. Unlike the elements before it, iron refuses to burn. It hoards energy, and in doing so, it seals the star's fate. Without fusion to push back, the weight of 1 billion Earths presses down. The core shrinks, pressure mounts, and then, in less than a second, the core collapses at 1/4 the speed of light. At this moment, the laws of physics strain against themselves. Electrons are crushed into protons, forming neutrons in a fraction of a second. The star, once as wide as the solar system, now has a core no larger than a city. And then, everything collapses inward. A shockwave, more powerful than 1 trillion nuclear bombs, erupts from the core. The star has only one final act remaining, a supernova. The death of a supermassive star is not a silent passing. It is a final scream, brighter than an entire galaxy, a beacon of destruction and creation. For a brief moment, the universe watches as one of its titans falls, and yet, from death comes life. The explosion sows the cosmos with heavy elements, gold, silver, carbon, oxygen, the building blocks of planets, of oceans, of life itself. Every breath you take, every atom in your body was born in an explosion like this. For some stars, the story does not end here. If the core's mass is great enough, not even the force of neutrons can stop its collapse. Gravity tightens its grip, and then, the star vanishes. A singularity, a point of infinite density. Time distorts, space folds, the dead star becomes something else entirely, a hole in the fabric of reality itself. The universe is a cycle of creation and destruction. Every star that dies gives birth to another. Every explosion plants the seeds for new worlds, and somewhere in a distant galaxy, another supermassive star burns, unaware that its time too will come. We are the ashes of dead stars. The universe's story is written in us. Imagine standing on the precipice of creation and destruction, witnessing the grand finale of a supermassive star, a colossal entity that's lived for millions of years, now in its final throes. This is the story of stellar death, where gravity, energy, and matter interplay in a cosmic ballet. Stars are born from nebulous clouds of gas and dust, where gravity pulls the material together, igniting nuclear fusion in a young protostar. In this fiery cauldron, hydrogen atoms smash together, forming helium and releasing vast amounts of energy. Einstein's famous equation, E=mc2, explains this transformation, mass converted to pure energy. As our star ages, it exhausts its hydrogen and turns to helium, then carbon, oxygen, and so on. These fusion processes happen in layers, like the skins of an onion. Each layer burns hotter and faster until it reaches iron. Iron is the star's nemesis. Unlike lighter elements, iron absorbs energy rather than releasing it. When iron accumulates in the core, the star is doomed, as it can no longer support itself against gravitational collapse. In a blink of an eye, the core collapses at 1/4 the speed of light. Protons and electrons smash together to form neutrons, releasing a burst of energy. The core tightens its grip as gravity wins the battle. Then the supernova, the star's final roar. A shockwave rips through the outer layers, blasting them into space with more energy than our sun will emit in its entire lifetime. For a brief moment, the supernova outshines an entire galaxy. What remains is either a neutron star or, if the core is massive enough, a black hole. Neutron stars spin rapidly, acting as cosmic lighthouses, but for the heaviest cores, gravity's victory is complete, and a black hole forms, a region of space where not even light can escape. But even in destruction, stars give life. The supernova spreads its elements into space, seeding new nebulae and new stars. Every atom in your body was forged in the heart of a dying star. We are the universe made conscious. We are the ashes of dead stars.